today, not open storage, not, no, I'm just joking. So it's all about, future is all about open source, and we will discuss open storage and open source software today. Our first speaker is Ben Cherian from Inktank. He is VP of Strategic Development. Why don't you introduce yourself?
Sure. Hi guys, how you doing? Thank you for showing up. Not that interesting. There's probably other talks to go to, so just giving you guys an out in case you want to leave now.
Do you want to see these guys?
Yeah, no, I'll be really quick because I'm waiting for these guys too. So I work for a company called Inktank. I don't know if you guys are familiar with Inktank, but we are the primary sponsors of a open source platform, unified storage platform called Ceph. And it does block storage and block, file, and object storage as part of the same platform. I'm actually a replacement speaker. The person that was supposed to come over here and start talking about open responses to storage couldn't make it. And when I got this invite to talk, I was like, well, what should I talk about? I could talk about what you're talking about, but he wanted to save his presentation. So I was like, all right, let me come up with a presentation of my own. And he told me, you should talk about what you know. And what I know, or what I've been involved with in the recent past, is Inktank. I actually came from a company called DreamHost. Inktank spun out of DreamHost, and our chief architect, or CTO, is Sage Weil, who was one of the founders of DreamHost, and he's the one that came out with the Ceph project. And so my familiarity with open technologies was way before that, but in terms of being part of a project that was really about open technologies, it started at DreamHost. I went afterwards to a company called Midakura, which is a network virtualization company, and one of the things that's a fairly hot topic right now is software-defined this and that, software-defined storage, software-defined networking, the software-defined data center, and what that all means. And then I recently rejoined my patriots at Inktank and decided to run up partnerships and alliances over there, and that's what I do right now. So when he was talking to me about talk about what you know, I was thinking, well, I do have quite a bit of understanding about infrastructure as a service with DreamHost, because that was under my umbrella. The Ceph project was under my umbrella, software-defined storage, and I also understand software-defined networking. And I see some themes around all of this that I'm going to talk about, and then I'm going to also talk about how open fits into that. So I'll try to get through these fairly quickly, because these guys are way more interesting than me. How many people think software-defined storage or software-defined networking is a marketing term? Only 1, 2, 3. Okay. Is that like everybody? Let's see who does it. Who doesn't? That guy. So there's a couple of people. So like most people think it's a marketing term. Some people think it's
3 out of 4 dentists or something.
Yeah, exactly. Okay, all right. No, I think, and those of you that think it's real, how many think it's actually real today? All right, a few people. I'm sure. Yeah. I'm sure everyone who raised their hand is an SDN vendor or an SDS vendor. Excellent.
I'm actually a customer.
Oh, look at that. So you're one of these. Anyone here who's deployed it? So you've deployed it. You worked with it. So it's very real to you. No, this is great. No, this is very good. This is very good. So like I think that is a healthy sentiment. That's something that a lot of people think. There's anytime a new term comes out, whether it's cloud or software-defined whatever, there's a whole deal of marketing bullshit that comes in beforehand that screws up the term for everyone else who's trying to use it in a normal way. This is one of those categories where I see, and in all of these people that are going after software-defined this or that, there's some trends, I think, in terms of the use cases. The trends are hyperscale data centers, large web-scale applications, cloud infrastructure, big data. And the theme I see over here is these are people that are looking at large data sets, large operations. They're trying to find a way to simplify a lot of that. Now, when I look at both of these, which is software-defined networking or software-defined storage, I feel like there's a handful of things that really, for me, define what that looks like. One of the things is Abstraction, I'll get into the idea of what that means. Accessibility, scalability, manageability. It runs on commodity hardware. There's no single points of failure. It has a shared nothing architecture. All of these things are, I think, fairly important tenets. When you talk to some people that have software-defined this or that and might not have one of these pieces, and I think that's fine as well. It's just kind of a loose idea of what software-defined whatever means, right? And when I look at most products, they usually do a pretty good job of checking off most of these boxes along the way. Let's talk about the first point. I don't think I have to talk about this too much given the audience, but abstraction. What is abstraction? Abstraction is a pretty fundamental concept in computer science, and by the idea of abstracting a very complex piece of technology and coming up with some sort of interface to that technology where you don't really have to get into the low-level details, you're able to build very complex systems without knowing as much about it. What I think is a fairly standard approach in software-defined whatever is the idea of separation of the control and the data plane and abstracting those two units. And by separating it, you end up with this idea that you can end up having some sort of scalability in the system, right? And by abstracting it away, you end up giving the ability to programmatically access it. And these are really, I think, fundamental concepts on how software-defined whatever works. I'm just going to call it that from now on, software-defined whatever. The control plane handles all of the management functions. The data plane handles where the data resides. And networking, within networking, the control plane handles things like flow setup, flow teardown, installing packet transformation rules, things of that sort. Within storage, it handles things like auto-balancing, cleanup, replication. They're tasks that sometimes in legacy systems are handled within the system because the control plane and the data plane are munched together. But in a software-defined system, these things are separated and logically separated as well. And the data plane is where the data designs or where the data resides or the rules are set. The big point over here is by abstracting all of this away, software-defined whatever treats the underlying components as individual fungible units. And this is a pretty important idea, right? The big concept here is if you can actually access each one of these pieces individually and they're fungible, and by truly meaning fungible, it means that one is equal to another and they're fairly disposable along the way. And there's common access protocols for all of this, whether it's storage access protocols like S3 or Swift, or whether it's networking protocols like OVSDB or OpenFlow. Whichever protocols you're using to access this, as long as there's some sort of common language set in order to be able to do this. The benefit is that application developers and people that are making complex systems can end up treating this underlying piece as something that is fairly disposable. And by doing so, you can end up vastly increasing your manageability of whatever application you're programming to this bottommost layer over here. And I think a lot of this is one of the reasons why things like object storage is getting a lot of play in the hyperscale data center world and the web storage world, because they're seeing that the uptake of it, the accessibility of it, the ability to go from one system to the other by making the northbound API, which is the S3 API, the primary API, and not really caring about the implementation details behind it. That's fairly important, and it gives you that idea of transference between platforms that are dissimilar. That is a good idea. It ends up with a lot of really unique multiple vendor collaboration that ends up pushing these ideas forward. Within another point having to do with it is these systems are for the most part self-managing. They're self-managing. They pay attention to each other. All the nodes are generally autonomous. There's intelligence in the nodes. They all talk to each other. They try to keep what a consistent state is. So if you're managing clusters and one of your nodes in a cluster drops, the system knows about it and reacts, whether it rebalances the data to react to that, or whether if you're doing something like a large network and a router ends up failing and you have a controller that's watching it, you can route paths, you can program routes around the path that's failed, and that's actually a pretty interesting use case as well. But within networking and storage, you basically have some sort of controller architecture that's watching all of the pieces and saying, this is where it fails, this is what we have to do, take care of it. That intelligence is separated from where the actual data resides or where pieces live. And it's generally self-managing. What I've seen in practice, at least in DreamHost, we have a 5 petabyte cluster that's managed by half an employee's time, and it really has nothing to do with managing Ceph at all. It has more to do with replacing failed hard drives, because these hard drives are crap and they crash all the time. So we need people that are like dropping in new drives all the time in order to make the system keep on going. But even if we didn't actually have people that were dropping in drives left and right into the system, we're watching the failure rates, we're rebalancing the data. It can live with a little bit of chaos in it and still be up and consistent. And that's something that is a unique idea. I don't think it's something that's a very common approach to storage. And if you take the previous paradigm, you end up having a lot of storage administrators and network administrators managing instances of routers and switches, or NetApp gear, EMC boxes, and things of that sort. And that paradigm is definitely not scalable as you get into the large petabyte scale. So you got to find some way on how to make all this self-managing, and software-defined X does that for you. Distributed by nature, the idea is really that you don't want to have a shared anything architecture in your system. You want to make sure that everything is completely distributed, there's no single points of failure. And the common approach to building these types of systems are building very intelligent distributed systems, right? And the basic idea behind that is the separation of the control plane versus the data plane, and finding ways to scale them separately, which when you try to scale them together, that's where you end up having to scale up rather than scale out. So most of these systems that are going towards this approach, they're distributed by nature. Every node is autonomous. There's a lot of intelligence at the edges. The edges all communicate with each other to maintain optimal state. Some examples are Ceph, and also back where I used to work at this company called Midakura, they had a product called MitoNet, which did virtual networking as well, and was very much like this. And the difference is these people weren't networking people, and they weren't inherently storage people. They're distributed systems people that are trying to attack a networking and a storage problem. That's a fundamental difference than the way that most people in that space attacks it. And I saw this over and over again. And now with the move to larger scale environments, it's becoming much more necessary. There's also a feeling within all of these software-defined approaches to use commodity gear, some sort of commodity gear, whether it's x86 boxes, whether it's very cheap open flow switches, whether it's using servers that have Open vSwitch running on them in order to be able to handle some of the networking pieces. But the idea is that these systems end up pushing away from the proprietary systems and start pushing you towards systems that are commodity. Number one, if you end up using this commodity in a reasonable way, you can end up having a much lower cost system. Number two, if you put a lot of work into the architecture of these systems, it can be just as performant as some of this very purpose-built architecture. It's not always as great, but it could be near, And as systems get better and better, and as systems get tweaked for particular architectures, the performance is going to get better and better over time. But the idea is try to use as much commodity gear as you can. Don't let proprietary gear get in the way in terms of defining the architecture of your storage or your networking solution. I mentioned this a little while ago, but limiting your failure domains is a very important thing. In all of these systems, one of the things that causes a lot of operational headaches, and those operational headaches cost real dollar shutdown, and when you're shoving a whole bunch of data into one system, having a single point of failure is just not doable at all, and having a shared nothing architecture where you don't have these contention issues is a big deal. And the architecture of most systems that call themselves shared software defined follow these rules, right? And Ceph, the company, or Inktank, the company I work for, happens to be one of these companies. But like I say, I'm just kind of noting themes that I see more than anything else. So, who cares, right? Well, you know, it means something to different organizations. And if you're an IT organization and you have a specific use case in mind, let's say your use case is, I want to use OpenStack and I want to have block storage. Well, that's a use case, right? Well, how do you end up making sure that that organization has the ability to roll out with something like a software-based product that runs on commodity gear that is a software-defined system? This is not from your storage team that's generally doing this. It's generally your systems group, it's your cloud group, it's a different group that's responsible for it rather than the people that normally are in charge of storage. So there is some rethinking that has to do on how the IT organization is organized. And I think that some of the things that people need to understand is there's a different approach to maintaining systems that are distributed systems than there is to maintaining systems that aren't, right? And along with that thinking is the idea of introducing DevOps culture and DevOps training within the company. Now, all of this stuff takes a lot of time. The technology is the easiest part of it all, believe it or not. I mean, it took Ceph, it's been 10 years since this has been a project, and it's just now getting to the point where we're getting traction, and we've built a company on it. That's the easy part. The hard part is the people and the process, right? Virtualization has been around since 1999 in terms of server virtualization, at least in how we know it right now. We only have a 60% virtualization rate in terms of workloads, right? That means there's 40% that it either doesn't work for or people are not moving towards it, and there's a lot of organizations that haven't adopted virtualization yet. So, you know, it takes people a long time to move, very, very long time, and very, very long time to move. What does it mean to the current ecosystem? Well, both of these have a very strong potential to disrupt the larger companies. Why? Because these larger companies are fixated on not commodity gear. They're more fixated on their hardware sales. And as you introduce these software-defined storage and software-defined networking concepts, it has the potential to hurt it from the bottom up. The money's in the upper layers. I really believe that. Right now in this market, there's a lot of Goliaths, there's a handful of Goliaths, and there's a few Davids that are solving these problems from a small company point of view. The thing is, these big companies have large distribution, so how do you end up fighting against these large organizations and building a company that's a small company that can fight against the EMCs, the NetApps, and the other companies of this world? How do you get the reach? And this brings me back to the final point, which was probably the title of the talk anyway. You need to use open source as a distribution model. It's a really easy way to get in there. Barrier to entry is low. Early adopters have a lot of patience. You have community involvement. You have a lot more companies working on fixing problems together. You'll have people that are partners and people that are adapting their technologies to fit better. The conversations I'm having as part of Ceph and Inktank is with, you know, component vendors and processor vendors and server manufacturers. And as a closed product, I would never have this ability to have this conversation a year and a half into our existence. And also, nobody wants proprietary lock-in. Right now, open source is a first-class citizen in the infrastructure software world. OpenStack is kind of proving that. Hadoop is also proving that. You got projects like Open Daylight. You have our project with Ceph. And all these large companies have policies on how to adopt open source. And there's just a huge strength of partners that build this. And with that, I'll move to the more interesting folks.
Thank you, Ben. Great presentation.